Okay, guys, we can start right now. So, hello everyone. It's a great honor to have you guys here to join our webinar today. And my name is Blair. I've been in the drone industry for many years. I used to work in DJI before, and now I'm responsible for global sales and marketing in BL-Ch4. So we are a company is dedicated to the drone enterprise solution, especially for the oil and gas industry. So we have a drone-based methane detector for the methane emission and linkage. And today we're gonna talk about it in 3 parts. So firstly, I will introduce why we need to talk about methane detection, especially in oil and gas industry, and why we need to detect methane as well. And then the second part, we will brief introduce the technology of methane detector in the market right now. And then the final part, I will brief introduce our methane detector. So if you want to know more details, feel free to write me on the email or our company email. You can ask for more details, or even we can arrange an online meeting to give you the introduction one-on-one. So first part, why we need to detect methane. And there are a few reasons. Firstly is environment concerns. So methane emission accounts for about 19% of total global greenhouse gas emission. And when we talk about greenhouse gases, usually we think of the carbon dioxide, but actually next to the carbon dioxide, methane is the second largest greenhouse gas, and it accounts for around 19% of the total global greenhouse gas emission. So that's why we need to detect methane, and we need to control the methane emission regarding the environment issue. And the second reason is for the public safety. So as we all know, methane is kind of very easy to get fires and explode gases, and it's deeply linked to the public safety because it's colorless and transparent, and it's very hard to detect by the eyes. In that case, methane detection becomes very difficult, and methane also become a big potential danger to the public safety. The second reason is the regulatory requirements. According to the IEA, the International Energy Agency, or every national regulations, they have the regulations regarding the methane emission or the linkage detection. So we're gonna talk about in the next slides regarding this one. And then the fourth reason is the advanced technology. So before the drone technology become more popular, before they have the traditional methods or technology to detect the methane, like the handheld or the stationary. And now we all use the drone technology to be more advanced and more applications you can use. And then the last reason is the corporate responsibility. So especially like the big oil and gas company like PetroChina or Shell or BP, this kind of big company, they have the corporate responsibility, and they have the policy from the company to reduce the methane emission. And when we talk about methane emission, usually it comes about methane detection as well. So first, the environment issue from the report in US EPA reports in 2022. So we can see the data from here. In 2019, the methane or the CH4 gas contains 9.5% of the whole greenhouse gas emission. And then in 2020, the CH4 gas increased to 11.5%. So this trend will still keep growing. So the methane emission will keep growing in the next decades. And then from the right pie chart, the data here, we can see that the most top three industry for the methane emission is firstly is the anti-fermentation industry, like the livestock farm. It contains 36%. And then the second is the oil and gas industry. It contains 32%. And then the third industry is the landfill and the waste, contains 17%. So that's why we talk about why the methane emission or detection is very important in oil and gas industry as well. And from that data, we can also see where we can find the clients, where if we use the methane detector, the top three industry that we can focus on those potential clients as well. And then for the since we talk about the methane emission, especially in oil and gas industry. So why we need to where we can find the methane emission or where we need to detect methane. So from the production to the end consumer side, the whole value chain or the whole value link, it will have the methane emission from the petrol production, the oil and gas production, and then the refinery and processing the gas or oil, and then you have the pipeline transportation to the end customers, like the residents or any chemical plants, and even on some storage station. So this whole supply chain or value chain will happen the methane emission. And when we talk about, of course, when we talk about emission, we'll also detect the methane as well. So here I put a paragraph from EPA US. They said approximately they have around 8,000 facilities they are required to report their emission annually. And when we talk about EPA, the regulations, I will talk about it in the next slides. Then for the public safety reasons, so as we would know, methane is a very kind of dangerous gas. It's very easy to get fired and explode when it contains around 4.4% to 70%. And it will explode. So here is some scenarios where news we will see in the past years. So like in the benzol oil pipeline explosion in 2021 August, Mexico Bay, the explosion caused 5 people deaths. And the second is the cattle farm, which will happen in Texas in 2023 April. So it caused 18,000 cattle deaths in the farm. And then the third is the mine lot explosion as well in 2020 October in Turkey, Banting mining sites. It caused 28 people deaths on that accident and disaster. And then fourth is the chemical plant explosion in 2019 November in China. There is a chemical plant because of the methane there is the explosion caused 22 people dead. So from that accident or disaster, we can see methane detection or methane management is very important to the public safety. So that's also an important reason why we need to detect methane. Then from the IEA International Energy Agency report, and this also from their website, there is a report in 2020. This report suggests that there are 4 kinds of regulations that the government or the country can do to manage the methane emission. Firstly is the more normative regulation, like the license requirements or the linkage detection or the maintenance technical standard. Like for example, in Nigeria, requires methane emission and computation permits. So you have this kind of license requirements. And for the linkage detection, like in Canada, the government need all the related companies need to report the linkage detection, and they also have the standard for that linkage detection report. So if you are interested in more details, because this is like the overall, the worldwide suggestion from the IEA. So the regulations will vary from country to country. So if you want to know more details on your specific country or area, you are feel free to come to us. We can share the technology as well. And then the second is the performance or the outcome-based regulation, like the strategic targets. For example, like the IEA have the whole strategic targets. By 2013, there is no methane emission. And then to each country or each area, they have their own, or even a specific oil and gas company, they have their own strategic targets. And then we have the economic means to regulate the methane emission as well. So like the taxes or fees, for example, like in Norway, they extend the carbon taxes to cover the methane emission from the oil and the gas sector as well. So that means if you want to do the methane emission, you need to pay for the taxes. And some emission trading or credits and other financially sensitive. So according to different countries' regulation. And then the fourth way is the for information-based regulation, like the emission estimates or the measurement requirements. For example, like how you measure the methane, and reporting requirements as well. This regulation is especially happening in US. And since US have the new regulation for this kind of information-based regulation. So like in US, they have a law, OOOA and OOOB, will regulate the exactly what the details, the measurement requirements and the reporting requirements as well. So if you are interested in this one, you can like go online to search the OOOA and OOOB from US. And then here is the top 20 gas richest countries in the world, like Brazil, Canada. They all have different ways of regulation. And for the full dot, it means the regulation happens in the nationwide. And for the half dot means this is the regional state policy, not the whole nationwide. So from this Excel, we can see like in Brazil, Canada, US, Mexico, Nigeria, This kind of countries, they have very extensive and completed regulation of management system for the methane emission. And then for those countries, for example, like China, Iraq, Iran, they have lack of the complete and extensive regulation regarding the methane emission. But that also shows they still have a good potential market for methane emission and methane detection as well. So we believe that the spread of increasing well-organized regulatory system in worldwide will be an irreversive trend worldwide. And then we talk about the technology of detecting methane. So before the drones, we have the handheld detector, especially specific in the indoor detection or some small area. You can use the handheld. And then we have the stationary detector. So especially it's more popular in the chemistry park or some area you need to detect on the ground. And then beside that kind of use case or scenario, if you want to fly a drone which a human being cannot access to, or some area is very dangerous for people to access, then you have to use the drone with the drone payload. So right now for the drone payloads, the technology, we have some infrared technology payload. And also we have the OGI technology. And then we also have the TD-LAS technology. For our payload, we use the TD-LAS technology. So here, before we go more details, here is the brief introduction regarding each technological principle. Like, for example, like infrared technology. So usually they will absorb the gases in a certain tankage, and then that the infrared will test it. So this kind of technology, the advantage is by using this kind of technology, is very cheap. The cost is very low. But the disadvantage is the concentration, or the methane concentration is not that accurate. And then the second technology is OGI. So it's kind of method of using thermal infrared camera to visualize the gases. So means it can make the transparent the methane gas into visualize the gases. You can see it from the screen or some monitoring. And then this technology, the advantage is you can see, you can put the methane transparent gas into visualized gas. You can see it in it very clearly. But the disadvantage for this advantage is you can't calculate the concentration. For example, like some government, you regarding the reporting format, you need to have the concentration. Then this advantage is not that perfectly. And then for the TD-LAS technology, we use this kind of technology. So we use a turnable laser, and this laser can only absorbed by CH4. And after we release the laser, then the CH4 will absorb it, and we will calculate the concentration based on the absorption. So this technology is, the advantage is that it's very accurate to detect methane, because this technology can only detect methane or CH4. So the accuracy is very high, and also you can calculate concentration. The disadvantage is this kind of technology, the cost is a little bit higher than infrared. So then for the applications where the use case for methane link detection, we have this kind of scenario. So firstly, of course, the oil and gas pipeline detection, and then some refinery facility detection as well. And then for some residence area, like the urban natural gas detection from the apartments. Like in China, we do this a lot. And then some chemistry park detection, like I mentioned in the previous slides. And then also we have the landfill detection. So because some landfill, they will also produce the CH4. And then some farm CH4 detection as well. Then for our products, for our sensor, we have 5 modules. We have the laser receiver, the laser indicator, laser emission, RGB camera. This RGB camera is basically for when there is a linkage, then this camera will take a picture. And after that, you can find the linkage points very quickly and more efficiently by using this RGB camera. And then we also have a laser range finder to help to locate the linkage site more accurate. And our products is highly integrated with DJI Matrix 300 and Matrix 350, and it's play and plug. So it's very easy to install, similar like DJI other payloads. And then beside the hardware, from the software side, we have an application which you can install in DJI pilots. And after that, you can do the like the flight mission planning or the real-time concentration data display on the pilot screen. And also you can change or set the payload, the parameter setting there. So like when we detect methane happen, the pilot will alarm, and also you can see the curve on the screen as well. And then this one is besides the application in the pilots, we also have a cloud platform for PC. And also this cloud platform, you can customize to your local server. For this cloud platform, after you fly and end the mission, you can generate the reports from this cloud platform. And besides that, you can also do the mission planning and the flight mission monitoring and live video checking, parameter setting as well. And also we'll have the data storage and inspection report generation. And also we have a 3D map display here, you can see. So if there is linkage or no linkage happen, it will display here in a 3D map. And we can also remark it in red if there is a linkage, and remark the green area if there is no linkage. So here is the resulting reports after we fly. We will record the warning time, the CH4 concentration, and the numerals, and the relative altitude, and also the coordinates. And also there is a pictures we will take if there is a linkage. So after you fly, you can generate these reports from our cloud platform. So here is a case study from Poland dinner. They check or they detect the methane from a local refinery. If you want to get more details regarding our production or any reports, demo reports, or some sample reports, you can feel free to contact us. So here is the case study from a New Zealand dinner. So they detect methane for some pipeline area. And that's pretty much for the presentation today.